Alright y'all, today we're going to be talking about scale models, their application of similar polygons and ratios that we've been dealing with all chapter long. The first application is on a map. Okay, this map represents a scaled down version of the actual distances between each of these cities that are on here. Okay, so it tells us the scale is 0.75 inches is representing 6 miles in real life. We're going to use that to determine the actual distance from different cities on here, and we'll do this in two steps. Okay, our first step is just actually measuring. Okay, so you'll need your geometer for this. Pause the video if you need to grab that out. Okay, but we're going to measure between the two cities they give us. So the first step is Pineham and Menlo Fields. We want to find those on here. Okay, and we're supposed to measure between those, and to do that, you'll want to line up your geometer with one of the towns on 0, and the other town is what we look at the number for. Okay, so I'm going to use the middle of the dot to the middle of the dot, but just try to line it up where you're in the same spot of the dot for both of them. And we're going to name, we're going to measure these distances to the nearest tick mark, okay, which is the nearest 1/16 of an inch. Okay, if you line these ones up carefully, it looks like this one's right at an inch. So that's step 1. Go ahead and write your 1 inch, whatever you get. Step 2 is actually using our scale that we're given to solve for the actual distance on real life situations. So take your 0.75 inches and put it over your 6 miles just like you're given in your scale. And we're going to set it equal to this 1 inch that we got on top to match up over x to find the number of miles. We'll cross multiply to solve here. So x equals, 0.75x equals 6. And then you just divide by your 0.75 on both sides. Okay, throw that in your calculator. And we should get 8 miles for this one. Okay, we're going to repeat that process for these next ones. Okay, North Park to Needham Beach there. Okay, so find your two towns first. Line one up with 0. And the other one. Okay, pause the video to measure that for me, please. Okay, this one went past the whole number 2 inches, 1 tick mark. So this is 2 and 1 over 16. So that top number is how many tick marks, and the bottom number is always over 16 before we reduce. Alright, so when we're setting this one up, the first part stays the same, 0.75 inches over 6 miles. But the second part, we're using this number instead. It's not good for us to have a mixed number or a fraction at all inside of another fraction. So what I want you to do with this is in your calculator, you'll take your whole number and you'll add it to your fraction. So 2 plus 1 over 16 is going to get that whole thing as a decimal for us. We're going to use this entire decimal on our problem here. So we'll write 2.0625 with the inches. Okay, put a little plus sign in there so you remember what you did in your calculator. And then over x miles again. So we'll cross multiply just like last time. We got 0.75x. Okay, but in our calculator we already have that number. Just multiply it by your 6. And then we know we're going to have to divide that by our 0.75 as well. Okay, so 12.375, x ended up being 16.5 miles. Alright, last one is on you. Pause the video, take care of it. Okay, this one, our x ended up being, our distance ended up being about 1.5. Okay, so that would mean your x is 12. If you were a little bit off here, say you thought this was 1 and 7 out of 16 instead of 8 out of 16, that actually would be okay for this one because it wasn't quite to that 1.5. We just want to pick the closest. So if you had a little bit under 12, that would have worked as well. All right, next thing we're going to talk about are some word problems with three-dimensional models. So that was a two-dimensional, just a flat map. This one says a doll house that is 15 inches tall is a scale model of a real house which height is 20. It asks for the scale. That thing we were just dealing with was the scale. It represented the two different measurements, one on the drawing and one being the real-life number. So when we set these up, it's always going to be your model on top over the actual size on the bottom. And so we'll take our numbers and plop them in. So 15 inches was our dollhouse, and 20 feet was our actual house size. And what we're going to do here is just reduce. When we're talking about a scale factor here, we want it to be the simplest as possible. We don't need these to match. We got to keep our labels attached to our answer. We'll just reduce our numbers. 5 goes into each, so we've got 3 inches over 4 feet, and that is the scale. Final answer. That's it. Now the second part says how many times as tall. That we have to convert into the same label. Okay, so for this one, when you see this, how many times, the labels have to match. So all it's asking you, which is why this is Part A and Part B, is to take what we get in Part A and convert them to the same label. Okay, so when you're converting, you have to know what it's worth. So 1 foot is worth 12 inches. We need to know that. Okay, but we just need to convert one of these. 3 inches is going to stay put because we don't want to change that to a fraction to make it feet. We're going to take our 4 feet and change it. So you could set up a proportion to solve this, but we're making it easier on ourselves. Pick the bigger label, and then you're going to multiply every time. So here, we're taking 4 feet times 12 to get 48 inches. So now we substitute in 3 inches over 48 inches, because that's what our 4 feet was, and then we reduce. You'll notice this time the inches cancel out. They match. This one we had to have our labels on there because they didn't match. Here we don't. And this reduces to 1 out of 16. And this tells us how many times the model is compared to the actual house. This is kind of worded a little backwards, but we just have to match the original. It's 1/16 as big as the house. Okay, just answering the question. All right, next one. Again, it's just asking for the scale here. It says the length of our model train is 18 inches, and it's a scale model of a train. So we're doing model over actual every time. So 18 inches over 48 feet. Watch your labels. The scale, you just write what you see, you reduce. Okay, so a 6 goes into both of these. 3 inches on the top, 8 feet on the bottom, and that's it. Okay, I want you to pause the video and try number 6 because it's very similar to what we've been doing. Okay, this one, you should have had 42 inches over 1750 feet. And that reduces to 3 inches over 125 feet. A couple more problems dealing with scale drawings, but going back to different types of questions. Okay, this one, it says an artist in Portland makes a bronze sculpture of dogs, and the ratio of the height of a sculpture to the actual height is 2 to 3. So they give us a ratio, and it gives sculpture to actual. Okay, so our sculpture is our model. It's the same pattern as before. What's different, though, is they don't give us labels on this. If we're not seeing labels, that's because the labels are canceling, kind of like what we had on 4B. If they cancel, they had to match to begin with. So it's telling us the top and the bottom are in the same label here. So if we keep reading, we'll know what that is. It says if the height of the sculpture is 14 inches, so our sculpture gets 14 inches, then we want to find the height of the actual dog, so that has to be inches too in order for that to cancel. Okay, cross multiplying, we've got 2x equals 42, so x is 21, matching our label, inches. Alright. The next one, it says an architect drew a scale drawing of a new rectangular building. We're going to start this one by drawing out our building as a rectangle. It says the dimensions are 30 by 70. Okay, so we're going to put those on our picture. 30 feet, 70 feet. And he wants this drawing that we're making to be 1/20th of the size. Okay, so when we're talking about this 1/20, okay, you'll notice there's no labels on it, meaning we want to keep the label the same. Okay, so when we use that 1/20, we would still be in feet. But then it says, what must the dimensions of his drawing be in inches? So this just indicates that we have two steps here. First, use the scale to help us find what the drawing would look like, and then take that and convert it to inches. Okay, so step one is this word in math, of means multiply. So when we say 1/20th of the actual size, just like we would say half of the size, we would take this and divide it by 2. When we're say 1/20th of the size, we're going to take this and divide it by 20. Okay, so 70 times 1/20 is the same thing as dividing by 20. Okay, it works out the same way. So this is 7/2 is 3.5 feet. Okay, we said the labels had to match since there weren't any. Same thing with the next one, 30 times 1/20. So that's 3/2 is 1.5 feet. And now we just have to change those to inches. Okay, so this is similar to what we were doing before. Because we have feet, we just have to multiply these each by 12 to get how many inches they are. So my first one here would be 42 inches, and my second one would be 18 inches, just multiplying those through. And we're just going to rewrite our dimensions kind of like they did. They went 30 feet by 70 feet. So our smaller number was 18, so 18 inches by 42 inches. And this is similar to what we did with our ratios at the beginning. This is using by instead of dot dot, but it's very similar. Alright, backside. You got a bunch of space on number 9 because we're going to do a drawing for this one. It says the Parthenon is a rectangular structure, so we're going to start out like last time, just drawing a little sketch. And it says 100 foot by 230. So 100 here, 230. You'll notice I'm putting labels on everything. That's important for these questions because some of them the labels match and some of them don't. We got to keep track of that. Then it says use those measurements and a geometer to draw a scale model of the base of the structure using 1 inch representing 40 feet. So our job is to 1, find what the scale dimensions would be, but then 2, actually draw it. Okay, so first thing is we're going to use this. Okay, when we're given a scale, we're going to write it as a fraction. 1 inch is 40 feet. Okay, but here we can't just multiply by those because our labels don't match. We're setting up a proportion where they go. Okay, we've got both of these being feet. We're going to do one at a time. So the first dimension, we've got x over 100 to solve. So when we look at this, looking at my labels answer here is going to be in inches. It's different than the last time. So this says 40x equals 100, and we're just dividing that over. So x equals 5.75 inches. Labels matter. Then we're going for the second one and doing the same thing. So 1 inch over 40 feet equals x over the other side, 230 feet. So this time I've got 40x equals 230. Divide by 40. X equals, I got these flip-flopped. This was our 5.75. This one was 2.5. Sorry about that. Alright, but those are my dimensions. And now we're going to use them to just do a drawing. So we're going to take this and actually measure using our geometer. So we're scaling this up. I'm going to tell you 5.75 inches is pretty long, so we want to go this way with it. 2.5 we have to fit up and down. You may, when you're doing your drawing, go through some of this because it may not fit entirely below. That is okay. We're going to start at the bottom of your white space before problem 10 starts. Okay, grab your geometer And what you're going to do is measure off 5.75. So when you're looking at your geometer, I'm drawing a little mini version of it. Here's your 0, your 1, 2, 3, 4, 5, 6. Your 5.75 is 3/4 of the way. So you'll see a long tick mark in the middle of 5 and 6. That's your halfway mark. The 3/4 is the halfway mark again. So from there to 0, I want you to draw a straight line there, and then label it. Okay, pause the video if you need more time to take care of that. Okay, from there what you're going to do is take one of your rectangles or your boxes on your geometer and trace the corner lining this up. Okay, so we're just making an L. There's part of it, and then go up with it. That ensures this is actually a right angle. Okay, you're going to actually trace it so that's straight. Same thing here on the other corner. We're going a backwards L. You're going to line up the bottom of your square or rectangle and then go straight up from there to make sure that's a right angle. Okay, once you've done that, we're going to just measure upwards on both of these 2.5. Okay, so here's your 2 and 3. From there to there on your geometer, starting at this corner, you're going to measure off your 2.5 on both sides. Okay, pause the video so you have time to finish that up because it will take a little bit. Last step is connect corner to corner, and yours should actually have right angle boxes. It shouldn't be slanted. I just did mine without measuring here, and you did. Okay, but it should look something like this when you're done. 4 right angle boxes on each part, and then your labels on each side. Alright, number 10, and a couple of these other ones here, are review from things we've done before. We've done problems with shadows. The only difference here is you'll see the labels don't match. We learned that the labels don't match with scales often, and that's okay. Okay, but we're still going to draw out a visual. Okay, we've got a ground since there's a shadow involved, and one's a 36-inch yardstick casting a 21-foot shadow. Okay, so my 21 foot is longer than 36 inches. Okay, but then we're just going to connect them with a right angle like we've been doing. Okay, then our next one, it says how tall is a building. Okay, so we're drawing a building. We don't know how tall it is, so there's the X, and this shadow is 168. Go in the same direction. 168 feet. Or redraw that so it's actually semi-straight at least. Okay, from there, right angle box, and we're looking at solving for this side. But if we check this out to begin with, what's really important here is that we're actually paying attention to what goes with what. So we've got our 36 matching up with X. This says inches. This should say inches too, just like the feet are matching up with the feet. So we're going to include those labels as we write this. 36 inches over X inches is the same thing as 21 feet over 168 feet. Okay, and then we're just going to go ahead and cross multiply. I'll give you a little bit to do that. Okay, I'm just going to do this in my calculator here. 36 times the 168, and then we want to divide that by the 21, which gives us 288 inches. That's it. Alright, Sam wants to enlarge or make a triangle bigger, and the first one has sides of 3, 6, and 6 inches. If the shortest side of the new triangle is 13 inches, how long will the other two sides be? Okay, so we don't have to measure this out to size. We're just going to sketch it. Pick a triangle that has two sides that look like they're the same. So on your geometer, you can use number 1. And then we're going to label those numbers. 3 is the different side, and the other two that match are the 6. But again, labels are important. We're putting inches on all those. We want to enlarge this, so we're making it bigger. Okay, but you're welcome to just draw it the same size with that same shape if you want. And it says the shortest side of that new triangle is 13. Okay, I like using the same side just so I can easily see which one's the shortest. Okay, that's this bottom one. It is 13 inches. and we can see it's gotten bigger. We want to know how long the other sides are going to be. So we have to solve for this one and this one. Okay, but if our original triangle had two sides that were matching, we're still going to have two sides that are matching for the second one. So we're going to put x down, but this side will just be the same as this number once we get it. If you had two different numbers, you would put x and y and solve for them separately. Okay? This one it's not necessary, because we're going to use this 6 with that x, and then this 3 with that 13. So 6 inches over x equals 3 inches over 13. So they're all inches here, nothing to worry about with your labels. Alright, so we've got 3x equals 78 here. So dividing that over, x equals 26, putting inches on, and we're done. The very last problem is dealing with a ladder. Okay, so we've got a ground, and we've got a ladder leaning against a building. So we're drawing a building. Our ladder is going to be leaning, so it's the slanted side. Draw some rungs on there to help you remember that's the ladder side. And this is 9 foot long. And it says against the building that's 6 foot off the ground. Okay, so we've got two other sides here, this one and this one. This one it says it's against the building 6 above the ground. If it is above the ground, it cannot be the distance on the ground. It has to be this distance. So there's our 6. Okay, then it says, at what height would a 15-foot ladder touch a building? Okay, so we're going to go and draw a new building. Even though it's talking about the same one, this is just going to help us. And this time, this is 15 feet. Now it says the same angle with the ground, so here and here are the same. And we want to know how high it would be. High is always this. It's going to match up the same part of the triangle as the last one. Okay, and we're just going to solve it the same way. 9 goes with 15. 6 goes with x. So we've got 9 times x. 15 times 6 is 90. Divide your 9 over. And our final answer is x equals 10. Paying attention to our labels. Again, this one, they're all feet, so no worries. Okay, if you have any struggle with the homework, please come see me to get some extra help.